How's it going, everybody? Welcome to Math with Mr. Stevens. Today we're going to be in lesson 16, moving forward a little bit, working on trying to find the slope of non-vertical lines. We're going to be starting on page 181 in your book. That is the first and second examples of lesson 16 in module 4. So, where we last left off, we were finding essentially the slope of a bunch of different lines. We found a point here and a point here, and then we looked at how we get from one point on that line to the other point by going up or down and then left and right. So we were using those directional values of going up a certain amount or down a certain amount and then going left or right a certain amount, and then recognizing that as the change in y and the change in x. We're going to be using that same strategy here, just we're going to be taking it up a notch. In this particular case with lesson 16, example 1 actually does not give you the 2 points that you are supposed to compare. You have to create those points on your own. But it's totally okay, because it's very, very easy to do this. All you have to do is something we said before, is look for these points that fall at whole number values. Okay? Sometimes they'll be a little bit more difficult to find. Sometimes they'll be super easy to find. Like if you look at example 1, very easy to find whole number values where the points line up. Okay, we are at 1, -2. We are at 2, 1. We're at 3, 4. And we're at, well, actually, technically we would be up there at, what was that, 4, 7. Okay, so from here, we need to just pick any of these 2 points. We can pick literally any point. We can call this one A, B, C, or D. We can pick going from A to D. We could pick going from B to C. We could pick going from A to C, B to D, A to C. It doesn't matter. We could pick any point and go from that point to the next one to find our slope of our line. Okay? So I want you to take a second, pause, and find what is the slope of this line. So when we find the slope of this line, we have to look, we're going from A to B. Okay, I'm just going to start there, make it super easy. Just pick the first 2 points. To get from A to B, I have to go up 1, 2, 3. So it's up 3 and then to the right 1. Okay, we said up and down, those are positive values, or up is positive, down is negative, to the right is positive, and to the left is negative, just like on a number line. So we're going up and to the right. Both of those values have a positive value, so positive 3 divided by positive 1. Positive 3 goes on top because that's our change in y. Positive 1, that's our change in x, goes below. So that gives us a slope of 3. Okay? Now, we can also check this. As I said before, we could pick any other point. In fact, let's go from B to D. Let's go all the way up here from B to D. Okay, so to get there, I have to go up 1, 2, 3, 4, 5, 6, plus 6, and then I have to go to the right 2. Okay, so my change vertically is going up 6. My change horizontally is going to the right 2 to get from point B to point D up here. And when we do that, I get 6 divided by 2. 6 divided by 2 is also 3. Alright, so either way, I could use any point. I could go from point A to C, and guess what? I'm going to get some value of 3. That's just how it's going to work. That's how we find the slope. Okay, so we got a slope of 3 for that one. Let's look at example 2. Again, they don't give us points that we need to, they don't give us a P, they don't give us a Q, they don't give us an R. We have to essentially create our own points on this line where they meet at whole values. And then from there, go from whole value point to whole value point to determine what the slope is. So I'm going to pick this one right here, pick this one right here. We could go here, we could go here, we could even go down here. It doesn't actually matter. This one is at 1, 3. This one is at 2, 5. This one is at 3, 7. This one is at 0, 1. And this one is at -1, -1. Again, pretty straightforward. We just label a bunch of the points, we can pick any of these points. We actually have 5 of them to choose from: A, B, C, D, or E. And it doesn't matter. We're going to get the same slope anytime. We can go from A to D, we could go from B to E, we could go from A to C, from B to E, or B, I already said that one. It's all good. Okay? So I'm going to take the easy one. I'm just going to go from B to C. Okay? Go from 0, 1 to 1, 3. So I'm going to go up 2. And then we're going to go to the right 1. And so when I'm looking to find my slope should be what? Correct. Positive 2, at least hopefully you got it correct. Positive 2 over positive 1. It's going to give you a slope of 2 for M. Okay, remember M is our slope, as we said up there. And we need to remember our slope as being that letter M, simply because it's going to be useful in the future. Again, we could go from point A to point D. In fact, let's do that just for the sake of the argument. From point A to point D. So from here we're going up 1, 2, 3, 4, 5, 6, going up 6, and then we're going over 1, 2, 3, going 3 to the right. So now we have 6, positive 6 over positive 3. Let me slide that up a little bit. Positive 6 over positive 3. We reduce that down. 6 divided by 3 is 2. So again, we can and should use any point that meets that whole value to find our slope, going from one whole value point to another whole value point. One more. The last two have been whole value slopes, 3 and 2. Let's see if that continues. This one, we got a bigger coordinate plane section, and we also have more lines and more points on that line. So here, 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 and we actually have one down here too. Okay, again, we got 5 points. That's plenty. We only need 2. Plenty. So here we're at 2, 1. Down here we're at negative 1, negative 1. This is 5, 3. This is 8, 5. And this is 11, 7. Again, any of those point values we can use to find our slope. Any of them. Label A, B, C, D, E. We can go from B to D. In fact, that's where I'm going to go. So to go from B to D, I'm going from 1 to 5 vertically. Okay? So going from 1 to 5 vertically, that's an increase of 4. And then I'm going from 2 to 8 horizontally. So 1, 2, 3, 4, 5, 6. Oop, pen's going dead. That is an increase of 6 horizontally. So to go from B to D, I have to go up 4 to the right 6. So when we go to find the slope, it's a positive 4 over positive 6. 4 over 6, we can reduce that down to a fraction of 2/3. This is our slope. Our slope can also be fractional in value. Okay? And I want to say fractional to be very specific in that way, so that way we don't have to deal with as many decimals. Okay? When you have a number, even if it's an improper fraction, leave it as an improper fraction. If you can't get a whole value out of it, leave it as a fraction. Don't make your life more difficult. So, our slope here is 2/3. That's different than the other one. Not whole number values, but that's still okay. Slope is 2/3. We can go from A to E. Okay? And what I want us to think about is the next step is going to be using points to figure that out. So, vertically, we're at negative 1. Okay, our y value is a negative 1, so we're going from negative 1 to positive 7. This is where all that work on number lines comes in handy. How do you get from negative 1 to positive 7? Well, you have to increase by 8. So we have a horizontal increase of 8. Then we're going from negative 1 to positive 11. We have to think, well, how do we get from negative 1 to positive 11? That is a positive increase of 12. And so when we go to put this together as a fraction, get 8 over 12, positive 8 over positive 12. again, we can reduce both of these by 4. It's going to give you the same slope of 2/3. Any 2 points on a line can be used to find the slope. Adios.